And now to our next speaker of the afternoon / morning, Jennifer Schmeisser on Culinary Reactions. Over to you, Jennifer.
So my name is Jennifer Schmeisser, and I am the General Chemistry Lab Coordinator and Instructor at St. Lawrence University. I connect to this group through Jimmy. Jimmy and I did research together, or I guess we were in the same lab group in SFU. So just because most of you probably have never heard of St. Lawrence University, just 2 seconds. We are a 4-year liberal arts university in upstate New York. Relatively small at 2,400 students. Our class sizes are pretty small, between 10 and 40. We are a 4-year school. We do have chem majors, but this course that I'm going to tell you about today was not meant for majors. This course is specifically meant for the general ed requirement of natural science with lab that everybody has to graduate with at the end of their time at St. Lawrence. Okay, so the history of the culinary reactions. This was not developed by me in the beginning. I took the course and then created a COVID type course from it, but usually it's taught on campus, and 14 weeks, 3 hours of lecture, 1 3-hour lab per week. And before me, traditionally what they've been using is a food science textbook, and they do the labs, they do some cooking labs, they do some gen chem labs, and they do these in the dining hall facilities. So when we all left very quickly last year, we tried to make some courses for the students to finish up their degrees, because we didn't know what things were going to go in the fall. So I decided to teach a summer session, which is 5 weeks, and you just jam pack all of that 14 weeks into 5. So the students were getting 9, or the equivalent of 9 hours of lecture between videos, etc., and 3 labs per week. So there was a lot of time. Most students were only taking 1, but some students were trying to take 2 of those. And for labs, all of our labs we were doing, we did cooking labs in their home kitchens, and they were on Zoom. And for this course, I started out with 8 and ended with 5 students in my Zoom labs. Okay, so none of these students were going to be scientists, and I didn't feel like a textbook was a good idea for them. They wouldn't keep it. So instead of using a textbook, I decided to use a cookbook. So I found a cookbook that I thought was a little bit scientific, but also I really loved the cookbook. It's the Salt, Fat, Acid, Heat Cookbook by Samin Nosrat, and it's a cool little chemical structures in there so that students can learn a little bit. And then I supplemented that with some traditional chemistry textbooks that I just photocopied for them. And then we also used the Netflix documentary for 2-hour episodes on Netflix, and we watched those as we went through the class. So if you don't have a copy of this textbook, or cookbook, I guess you could say, it is set up so that all four different sections have different types of cooking associated with them. So what I wanted to do was break down those topics into things that I could get some chemistry in there for them. So my version of Samin's book there is the beginning. This ended up being about 5 times that big, but I just kind of switched the course material around until I found a way to kind of fit it to her topics while getting chemistry content in there. So this is what I ended up with, 3 different units and a final project. So we did introduction to flavor, and we had to get some chemical bonding fundamentals in because these kids would not have seen chemistry since 10th grade. So I needed to give them something so that we could go forward and look at some of the molecules. So then we started with the cooking and food preparation in Unit 2. So we started using her book kind of towards the end, and we did a heat section, and then we used structural molecules that I thought they'd be interested in, proteins, carbohydrates, to talk about how heat affects those types of molecules. And then finally, we used the first 3 sections of fat, salt, and acid, and we tried to pick up the rest of the chemistry from there and associate it with some recipes that they could make. And then at the end, well, kind of at the end, they had to start it at the beginning, but at the end, they they finished their final project, which was a fermentation reaction, which was their own choice. So they just decided something they wanted to ferment, and then we talked about it at the end of the semester. And we had somebody did cheese, somebody made hot sauce, somebody did pickled vegetables. So there was a real large separation between what students were interested in, but they came up with their own projects. They created procedures, they did all of that stuff, and then they presented it to me with a report. Okay, so obviously, I can't give you all the details, but 3 hours of lab, we did Monday, Wednesday, Friday, and I basically took one topic and created a lab and then gave them the course content before we got there. So anybody who is at all interested, anybody who's got to teach a lab online and wants to do something like this, I am happy to share as much stuff as I can with you. We've been in person for the whole year, so I don't think we're going to need this in the fall, but it was a great lab to teach them the scientific method while still having them have to actually do the work on their own. So we had to send them a bunch of stuff. Normally SLU would pay for the food, and we could not send them milk and those things that we needed. So basically what I did was I sent everything else to them, and in lieu of what they would spend on food, I sent them the course textbook. And then we kind of traded that off for them buying their own groceries. So I sent this as a lab kit. There were a million things in there. It took me about 2 weeks to put it together. And then also I sent them a bunch of things to go in their lab kit that had to be returned. So sent them by UPS, and then they sent them back by UPS. And then these are the things that they had to have, so they would know this all ahead of time. And they're pretty standard stuff, but I wanted to make sure that I got, we did the second part of the summer because I wanted them to use flour. And I'm sure you remember where we were with flour last year. So luckily we were at a point in which we could actually have flour. So they had to buy all of that pantry item stuff for before the lab course started. And then anything else that we used there for any of the particular labs, I would 1 week ahead of time, I would provide them with a grocery list so that they could get somebody in their house to go out and shop. So it was a big risk thinking we might actually have food at the end of the summer for them. Okay, so the way I structured it, because we weren't on campus and students had jobs, I had to be careful about synchronous versus asynchronous, especially with 18 hours. So I decided what to do would be to do quite a bit of the content ahead of time for them, and then have them do some worksheets, etc., and then give them their assessment when they got there. So before each lab, they had a bunch of videos to watch. They had to watch me do a video on content, most of the chemistry. They had to usually look at an online recipe and make a procedure from that. So I didn't give them the traditional Gen Chem procedures that you would normally get for the students would have to, or the students would be able to work from. It was all prepared by them by YouTube videos, and so they had to come in with that done. Then they would have a worksheet. They would complete that and upload it. They would arrive in lab, now having all the content for that particular lab, and they'd have a 10-minute quiz when they got there, and we would cook for 3 hours. Anything they could do stuff after as well. They would upload pictures of what they made at the end of it to feed somebody in their house so they could get some questions. And then they had to do a short report, because I really felt like the scientific method was what our students are missing when they leave the natural science with lab. So I thought, I just pose your questions, determine variables, identify biases. So they ended up learning some science, even though who knows what they would have carried with them as far as chemistry. So I thought I would, and I don't know, you'll have to tell me how many minutes I have here, because this
On to the last minute or so.
Okay, so if I can get off of this PowerPoint, let me stop share and then go back. I just want to show you one thing that we did the students what she would have handed in. So in one of our experiments, we made ghee. They all got a pound of butter, and then we all cooked it down, and then they had to take a picture of it. And some of them had light colored, some of them have dark colored. And then in that same lab, we did some infusion of oils using whatever they chose. So there was a lot of whatever you want. And for the stuff, this is basically what I gave them. So I didn't, spend a ton of time on giving them procedures. It was, this is what we're doing. These are the questions we're answering. And this is what I want you to answer before you put it in your report. But again, I would be happy to share anything that I got. And the only thing I would do differently, I would have been smarter and had them present their final project, which we didn't. And it was just such a rush that I totally never even thought about it. So that's my course.